There are two special cases for multiplying two binomials. One is the product of conjugates, and the other is squaring a binomial. Conjugates are expressions of the form a plus b and a minus b. That is, they have the same terms connected by different signs. So something like 2y plus 5 and 2y minus 5 are conjugates. Negative 3x minus 2 and negative 3x plus 2 are conjugates. Something special happens when we multiply conjugates. Let's consider the example x plus 3 times x minus 3. This is really two binomials, as I just said, so we can FOIL or remember that multiplying each term in the first binomial times each term in the second binomial will give us x times x, or x squared. X times negative 3 is negative 3x. Then 3 times x is plus 3x. And then 3 times negative 3 is negative 9. When we simplify, we get x squared minus 9. Because notice that the inner and outer products are opposites of each other. They are negative 3x plus 3x, which add to 0. So we get x squared minus 9. Let's look at another case. 2y plus 5 times 2y minus 5. 2y times 2y is 4y squared. 2y times negative 5 is negative 10y. 5 times 2y is plus 10y. And 5 times negative 5 is minus 25. So notice again the inner and outer terms add to 0, and we're left with 4y squared minus 25. In a general form, if we do a minus b times a plus b, that is, we multiply two conjugates, notice that we get a times a, or a squared. A times b is plus ab, minus b times a, which is the same thing as minus a times b, minus b times b, or minus b squared. So when we combine those, we get a squared minus b squared. So the product of conjugates results in what's called the difference of two squares. That's going to be important when we reverse this process and do what is called factoring. So the difference of two squares always comes from multiplying two conjugates together. Now, squaring a binomial is another special case. So squaring a binomial is when we have a sum or difference raised to the exponent of 2. So notice this is not where we just have 3x squared where we can square each factor. We have a sum, and we don't have a rule for that yet. So we would need to treat this as x plus 3 times x plus 3 and apply the rule for multiplying two binomials. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. So we get x squared plus 6x plus 9. Always true, when you square a binomial, you're going to get a trinomial. Look at another one. You have x minus 4 squared. That's x minus 4 times x minus 4. So we would get x times x is x squared. X times minus 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is plus 16. So here again we get x squared minus 8x plus 16. So squaring a binomial gives us a trinomial, and these are called perfect square trinomials. And if you want to get a general form for it, if we do a plus b quantity squared to get a plus b times a plus b, we would get a squared plus a times b plus b times a, or a times b, plus b squared. So that gives us a squared plus 2ab plus b squared. So that is, some people call this the bunny method. You have to, let me show you this. You have to square a and square b, and then you have to do ab times 2. But you don't really have to memorize any special formulas. If you just remember the FOIL method or the distribution method, you're going to be able to get the result exactly the way you need it.